Hello. So this is part of the video series where we are going to discuss application security, and we are going to focus on the password handling part of it in this video. All aspects of the password, how to store them in your application, and how maybe to do the hashing and identity federation or identity integration, all those scenarios. How to basically handle passwords for your software development. This will be the focus of this video. So before we start, the challenge around the cybersecurity in general is there are a number of different standards and frameworks available to date in the industry. For example, there is a NIST guideline, there are OS rules and controls, there is a BSA framework also there is ISO standard there 20001, and then there is National Security Agency from USA also providing the guidelines. Plus there are a number of guidelines and security policies from the country level also. For example, if you're looking for Saudi Arabia, or for example for any Gulf country, they definitely have their country level guidelines and security standards also there. Problem with all of these is, to date, we do not have one single framework in the industry which can basically comprehensively detail all the elements of the security or all the control that are needed. We have to basically play around with different frameworks and standards and try to address all of them, or as much as possible to cover all aspects of the security. So this is the to-date issue with the cyber security in general, is that there is no single standard or no single framework that covers all aspects of the security that is needed. So we really have to struggle with different standards and frameworks in order to come to a secured solution in the industry. So let us get to the discussion of password handling, which is the focus of our discussion today. So first thing is how to get the password. Before we talk about the password, the first question arises how to generate the password, how to get the password. Handling is always the secondary thing, right? So basically there are a number of online password generators also, and you can think of being very simple, you can think of a simple password in your mind also. But when it comes to securing your infrastructure, usually there are password generators, online password generators are also there. You can use them, but there is one weakness in using the online password generators, that you cannot really trust them. There are a number of websites available on the internet that can give you the complex password, but while they can give you the password, you can generate them, they can keep a copy of the generated password with them, and that is where the weakness starts actually. So before you do that, you can consider using your own script also. You can customize it, and you can use different type of random options and other parameters there to customize this to your needs, and that will always be more secure. And then there is general guideline that at least 12 characters should be there, and maximum it should be maximum length of 128 characters. Beyond that it should not go. So these are the combination of different controls from NIST, VSA and other OS rules that we have come across about the length only. And then it should never be stored in the clear text. Of course, we use encryption, hashing different format that we are going to discuss shortly. And then it should not be communicated through email, obviously. You do not want to distribute them just like that. And then there is little discussion before we get into more complex topics. Password rotation. Password rotation is another basically a lot discussed topic, because if you happen to know, both NIST and NCSC recommend again using it. They do not recommend enforcing the password rotation, because what happens actually is when people, they are very frequently rotating the password, they tend to forget it, and they tend to write it somewhere, or sometimes they are using the same patterns. In the new modern AI era, those patterns can be basically predicted, or this another creates a loophole. So with the passage of time, these standards, even Microsoft also, it has stopped mandating actually doing a password expiry. It's no more necessary. But there is one standard which banks mostly use, which is called PCI DSS. If you're going to enforce PCI DSS in your environment, like banks often do, they need to, then you really need to have the password rotation also. Password expiry need to be there. Otherwise, basically the advanced solution is to have a custom block list where some type of passwords are basically blocked. They cannot be set as a password. There is a customized list. For example, like for example common password that have already been used in the industry, 123 ABC, like that. There's a huge list basically there is, and the cloud providers also there, you can go and configure it. So that is also one thing you should consider. That is a rather better alternative to doing the password rotation. And besides that, if you do rotation, then there is common policy setting that are in alignment with all the standards that you should be setting up. So this is about the password generation. The key takeaway is use your own script if you want to generate complex passwords for your important virtual machines or applications or infrastructure machines anywhere. So that is one thing. Now, how about the scenario of basically storing the password in your application? You are doing a software development now, that you are tasked with the challenge or to store the user passwords. So as starting with a simple scenario. So basically, if you notice, if you have been using, like if you take the example of organizations that are storing the password, they usually use Microsoft Active Directory. We have most of the 90%, like let's say organizations in the world, they are using Active Directory as their main user store and storing passwords also there. You would be surprised to know that Active Directory actually never stores your password. There is no solution in the industry even now in 2025 available whereby you can use to extract a common text password from the Active Directory, any of the domain controller. You might be surprised to know that, because it never stores your password, it only stores the hash of it, and that is basically an irreversible hash. Because what it actually needs to do is only need to do the password matching. If the password matches or no, that is the only thing. There is only one technology available in Active Directory through which you can basically synchronize the password, which is called Microsoft. Its earlier name was Microsoft Identity Integration Server. Later on, it became Identity Lifecycle Manager Server, and then it kept on improving. They kept on improving this technology, but the only possibility with that was a hook, DLL they used to use to patch into the domain controller, whereby anybody setting the password, only at that point in time that password was basically communicated and copied, and that password was sent to any synchronizing agent, and that was considered to be a vulnerability as well in later point in time. Because ideally, for the password handling, the best practice in the industry is never to store the password as it is in the application. You just need to store the hash of it, because what you actually need to do for the password handling is you just need to match whether that password was exactly the same whether user initially provided or not. So you just need to store the hash of the password, which should be an irreversible hash, because if it's reversible, then you will be having a mechanism to know what the original password was. This is the only way where you can ensure that even administrators, they cannot play with the system to get to the password the user is setting. So this is a very good thing. Active Directory uses it, and many other identity stores also use the same mechanism. So this gives the user the comfort also, whereby when they are setting the password, they are comfortable that even the administrators, they won't be able to see exactly what password that they are setting. This is the good thing about it. And then there is additional care that need to be done for this web application, unlike Active Directory. So all that hashing also should be done on the back end, not on the front end. Because front end, the code is already there in the browser. If it's there, then basically that code can be copied. So you can know the algorithm at least, which is being used to hash the password. Alone, the leakage of that algorithm is considered a vulnerability. It's called pass the hash attack. Basically, it generates that possibility. So we don't do that. We pass the password onto the backend server, onto the HTTPS session, which is basically the encryption on the TLS 1.2 these days, which ensures that the traffic is encrypted, and then when it reaches to the backend, only then basically the hashing happens at the backend server. And then salt should be added before hashing. Basically, it adds further complexity to it. It gives another complexity layer to the hashing, further adding on to the irreversibility of the password. And then basically, if you go for the OS, they will recommend R12 ID hash algorithm, which is the industry best considered these days, by the way. So basically what happens is, in a nutshell, you provide a password to an application and they convert it into secure string. Secure string is just nothing but is a little newer variant of the classic string. Basically, in the memory also, when you are typing the password, the new secure string concept is to not to store the password directly in the memory, because the newer attacks these days they are very versatile. They can read the memory content also, and they can have a hook there. We can directly take the password there from there. So the secure string concept is just the encrypted part even present in the memory while you are typing that password. It's just a level above the normal security of the memory string that we had. And then basically from that you convert it back to the password and then normal string, and then add the salt there. And this is if you notice happening on the back end, and then it's become password plus salt. And then you add the hash function, which is, as we discussed, R1 IID function, and then you do the hash password. That is, you can store in the database, because there is no harm in storing that. But even then you cannot have the freedom to have it leaked basically, but it is a good store. At least it's a irreversible set of passwords that you are storing in your database. By the way, this is also what Active Directory does. It also stores that. If you need to store user ID and password, if there is a need in your application, this is the way to go. Every application basically at the minimum needs to store the admin password, right? Before, for example, if you develop any XYZ software or application, you need to have some admin login for it. Even the routers and devices, network devices, if you notice, they have to have some admin login, right? They already are. They need to store the password of it somewhere within itself, right? So this is normally the mechanism in the industry that is being used these days to store the password. Plus, as I said, every country or every region, they sometimes have their own regulations also, or their set of policies on so what must be used. As I said before, besides the standard that I already listed above, some countries, they are coming up with the recommendation of their own also, that this should be the hash functions or this and that. In case of course, black box applications like Active Directory, they cannot really enforce that. Some group policy settings are there, but not everything is 100% configurable. So when you are doing a custom development or developing your own application, you really need to ask them. So you need to see the country guidelines also, and you need to see all the latest industry standard also, as we discussed, NIST, VST, NSA, and all those frameworks. You have to scan them also, and you have to check for the local regulations also, like this is for the Saudi Arabia KSA regulations. This is the updated guidelines for them. So we have to really obey them. So in this case, OS is coming up with something very powerful, because this was the winner latest of the most powerful hash algorithm that we had. There is a little discussion on which one is better between the SHA 512 and R12, because they have been very closely matching with each other in terms of performance, but R12 came out to be highly resistant when it comes to all sort of attacks that we could do. Okay. Now it's basically so slow, and it's intentionally slow, because in this type of hashing you want to have something that is a bit slower actually. And that it was the winner of 2003 password hashing competition also. So this is just the algorithm. You can find such algorithms on on the GitHub also, and this is just an illustration of that. So after that, another scenario comes in. Let's suppose you have the password, you have your some admin logins also. Now you really want to let's say use the federation. You want to have a single sign-on, or you want to do the identity integration with Microsoft ADFS, or let's say suppose other identity federation solutions on the web, like Okta, like Identity Server, or Keycloak, for example. Then basically what you can do is you have to implement a protocol called SAML or OAuth, or there is another protocol, WSFed also. These are the protocols whereby basically you can federate your identity with the external identity stores. So basically you end up using a token, and that is mapping to your user, and that maps also to another equivalent user in some other identity store. And this protocol, OAuth2 or SAML, basically does the one-to-one mapping between them. So there is a configuration. For example, if you use the ADFS, Microsoft ADFS, you can configure it, you can configure the claims, and you can do the rest of the configuration. I'm going to do another detailed video on how to configure ADFS also, just in case you want to configure it for particular directory store or particular application. But basically the nutshell is you use your token and then you just federate to the another identity stores. In your application, as a part of this video, what I wanted to highlight is there are two libraries that you can use. There is Identity Server 4, which is no more free. In the recent past, they converted the license to commercially. You can purchase that, by the way. Or there is still one free option, which is called Keycloak. So you can use the Keycloak open source also, and it will give you OAuth 2 implementation. So your application can natively become OAuth 2 compatible, whereby you can be able to use the external application. So it will be like your web application, and you're using Google identities to let the user log into your application, or let's say Microsoft identity, whereby a user is using their logins. You would have seen many web applications that allow other identity stores to let the user log in instead of creating their own ID. Backend, actually what they are doing is doing just one-to-one mapping between that user and their own user. So this is one scenario, although this small discussion does not cover all the complexity of that, but this is one way to go with it. There is a benefit of basically of this approach. Let's suppose your primary identity is a Microsoft Active Directory, and you have just integrated your identity or application with the Active Directory. There are a number of ways to do that. If your Active Directory is your local store, you can use directly web application authentication, especially available in ASP.NET, whereby you can directly use the Microsoft AD identities, and user can provide the same user ID and password, and you can even enable single sign-on also with that, with a layer of plugins available on top of that. In fact, if you do Microsoft stack development, they provide all those things out of the box also. But still, if you want to be industry compliant or doesn't care for any particular identity store, you can use Keycloak or Identity Server 4, as I mentioned. There are other libraries also, but I'm just mentioning the two as an example here. So this is about identity federation, how to use the external identity store to authenticate or let them log in, where you have an existing mapping for that particular external federated identity. And then of course there is a concept of identity integration also. Identity integration concept basically came from Microsoft Identity Server, which was introduced way back in the past in 2003 basically, which later became Microsoft Identity Lifecycle Manager. And then basically the concept is just to do the password syncing of that. And I already explained it have a hook on the Microsoft Domain Controller, which lets you sync the password from different application to application. So that is about identity synchronization, identity integration, and identity federation. So there are three standards basically that govern the identity federation: WS-FED, OAuth 2, or SAML. And there is another scenario where you want to store the password. As you might have heard the solution like Thycotic or HashiCorp, whereby basically they are the password managers. So password manager is another solution whereby basically you can store your passwords. Let's suppose you want to develop an application or some small solution for your organization, whereby you want to actually store the password, let the user store the password and fetch them also for keeping the password or storing them there as a password manager. It is very easy to develop one such solution for yourself. Although there are a lot of solutions like HashiCorp is there, CrowdStrike is there, and many other companies that are doing that. But you can save some money here if you want to really develop it, because it's a relatively easy development. Because if you see the Gartner, what Gartner have to say about CyberArk, let's suppose, a common complaint about client is about cost. So if your need is only about a password manager, then be assured that developing that thing for yourself is really not a very big effort. Because what they actually are doing, let me try to explain you. So sometimes they come in the browser extension also, like LastPass, is one of the famous browser extension that let you store the password. But I am going to, in this part of the video, only going to the tip or focus on what they are doing at the back end basically. So let's suppose you already have a complex password which you generated from your script or whatever, or you already set in some other place and you want to just keep it. So there is of course front end or the portal or the web portal or the UI for the GUI application where you supply this password again in the secure string. What happens is behind the scene there is a encryption algorithm that is used. Normally that encryption algorithm is the main magic. I mean, all the big like HashiCorp and all those main pertinent players in the password manager, they are using the two-phase algorithm, and we are going to discuss shortly why. And then you have another database which is encrypted and audited database where the password is actually going to get stored in an encrypted form using the algorithm like two-phase. And this is only the one solution where you are actually storing the passwords. Now this database becomes very critical because from this database you can basically get back the original clear text passwords. And basically what happens with these password managers are integrated with your workflows, with your other systems, whereby they can extract the password and let the overall solution run, where the authentication need to happen for many workflows. So this is a very critical system you need to design with care and security. But this is the encryption that to date is the most powerful one that other password managers are also using, and you can easily implement also, which is why I emphasize that developing one such solution is relatively a simpler task, not a never-ending development or something that you really think that you need to buy or procure any out-of-the-box product. So coming back to the encryption algorithms. So this is sometime when developing your own solution, another good part is you can really follow the regulation that you want. For example, I have the sample regulation from Saudi Arabia, KSA regulation on block cipher. They emphasize on this and this for the type of requirements of encryption that you have. If you're developing your own password manager, you can have that also. So and also the benefit is of integration. So it will be a more integrated solution to your workflows, contrary to the one that you procure from, for example. Plus there is no learning curve because then developers will be mending it to the way or changing it to the way that is required for the workflows. So it's more flexible. And about the two-phase algorithm, basically is as of latest it is the most powerful. I mean the NIST report, what you see is feared best among the finalists where the extra hardware required to implement both encryption and decryption. So they have done the research. So what they found is that two-phase algorithm is the best, which is why most of the password managers they are using it and they prefer it over the traditional AES encryption, because this is the not the ordinary encryption. This is something where you are storing the most critical piece of information, which is called password. So you need to have the most sophisticated algorithm and which is prone to all the latest hacks that are there that can really penetrate those things. So this is a short discussion on how to develop and all the security around the password manager. We discussed basically how to store the password in your application using the password hashing of using the Argon ID algorithm, and then we have a two-phase algorithm if you really want to store the password in a way that you want to do the reverse clear text translation also. And then we discussed how to generate the password, the normal policies around the password, and the standards policies that are there. People say, as far as quantum computing is concerned, that it is going to really break all of these technologies, and then it will break all the system right away. But definitely there is no concrete solution to date, and even in 2025 there is still the timeline of around 20 years or like that for there's some really public thing to be out there that will really break the things. So for now, for the next 2 decades, you can be pretty safe, even considering the quantum and everything, that you have a really solid solution using these algorithms, and you really can rely on them. And also, can you tell you something? Basically, there is more work going on the quantum also, whereby they are releasing the libraries that can help you secure the existing algorithms that quantum will not be easily able to break. But that is also, all of that is in a work in progress. For now, there is nobody having any solution where they are using it to break all of the current encryption or hashing algorithms that are out there. So that is all for now a speculation only, and things to unfold in the time to come, which is nowhere somewhere near basically. So this is about only the password part of it, because application security is a vast topic. In the next series we are going to discuss the frameworks and other security controls that govern the other aspects of the security in the application. Thank you.